I welcome you all to Analytics Simplified, and in this video I will be taking a problem on Master's Theorem. So in case you haven't revised what Master's Theorem is, I suggest you follow the I button to have a look at how to solve a problem by using Master's Theorem. So in this problem we are given a recurrence relation that is of the form Tn is equal to 3 times of Tn by 2 plus n square, and what we are supposed to do is we are supposed to find out its time complexity by using Master's Theorem. So the first step in solving this problem is to try to convert this problem into the standard form. Okay, so if I take this function n square, if I call this function as fn, so by making use of reflexive property I can always write n square to be equal to, I can always replace n square with theta of n square. Okay. So what I will be doing is I will be making use of this reflexive property, and I will be replacing n square with theta of n square. So when I do this, my modified recurrence equation becomes 3 times of Tn by 2 plus theta of n square. The reason I have done is to because I had to convert this problem into the standard form, and the standard form was having a theta notation. Okay. Now if I compare this equation with the standard form, that is 8 n by b plus theta of n raised to the power k log n raised to the power p, what I have to do is I have to find out the values for these coefficients a, b, k and p. Okay, so these values will be found out by direct comparison. Okay, so what I can do is the recurrence equation can be written in the form 3 times Tn by 2 plus theta of n square, and instead of 1, because n square can be written as n square multiplied by 1, and see n square can be written as n square multiplied by 1, and instead of 1 what I am doing is I am writing log n raised to the power 0, because log n raised to the power 0 is also 1. Okay, so what I do is I rewrite the recurrence equation in the standard form. The purpose is to get the values for the coefficients a, b, k and p. Okay, and by direct comparison what I can find out is that the value of a is equal to 3, the value of b is equal to 2, the value of k the power is equal to 2, and the value of p is equal to 0. Okay, so my step 2 is completed. In step 1 what I try to do, I try to convert the problem in the standard form. In step 2 I try to find out the coefficient for the values a, b, k and p. Okay, and now in the step 3 what I will be doing is I will be trying to find out if the coefficients actually conform to the constraints. So what are the constraints? The value of a should be greater than or equal to 1. In our case it is equal to 3, which means constraint 1 is satisfied. Okay, so constraint 1 is satisfied. Then another constraint is that the value of b should be greater than 1. In our case it is equal to 2, which means constraint 2 is also satisfied. The third constraint is that the value of k should be greater than or equal to 0. In our case it is equal to 2, which means third constraint is also satisfied. And the last constraint is that p be a real number. So in this case p is equal to 0, which is again a real number. So what I find out is that the values that these coefficients hold, they are satisfying all these constraints, which means my problem can be solved by using Master's theorem. So the next step that we will be following is we will be having the value of a, and I will be comparing this value with b raised to the power k. The value of a you can already see it is equal to 3. The value of b raised to the power k is equal to 2 raised to the power 2. Okay, that is equal to 4. And in the next step I will be comparing value of a with b raised to the power k, and what I find out is that the value of a is less than b raised to the power k, which means our problem falls in case 3. Case 3 basically conforms to the situation when the value of a is less than b raised to the power k. Okay, so when we see that the case belongs to case 3, now I have to check the value of p. Now in this case the value of p is equal to 0, which means our time complexity can be written in the form of theta of n raised to the power k and multiplied by log n raised to the power p. Okay, so what I will be doing is I will be putting the values of k and p in this form. So after putting the values of k and p, k is equal to 2 and p is equal to 0, what I find out is that the value of the time complexity can be written as theta of n raised to the power 2 multiplied by log n raised to the power 0, which means the time complexity for this recurrence relation is equal to theta of n square, and this is also our answer. So we come to the end of this video. I hope you have followed through the different steps.